Good morning, all of you. Today's topic is optical pyrometers. Now, let us start about the optical pyrometer. So, its simple definition of optical pyrometer is a pyrometer that measure temperature by means of determining that intensity of light of a particular wavelength emitted by a hot body. So, this is the simple definition of optical pyrometers. Now we start about the basic principle of optical pyrometers. The principle of temperature measurement by brightness comparison is used to optical pyrometers. A color variation with a growth in temperature is taken as an index of temperature. Now, this optical pyrometer compares the brightness of image produced by temperature sources with that of reference temperature lamp, and the current in the lamp is adjusted until the brightness of the lamp is equal to the brightness of the image produced by the temperature sources. So, since the intensity of light, any wavelength depends on the temperature of the radiating object. So, the current pass through the lamp because a measure of the temperature of the temperature source when calibrated. So now we discuss about the main components of optical pyrometers. In this system, a observer, eyepiece, battery, rheostat, multimeter, outer tube, objective lens, and absorption screen, red filament, and temperature sources to be measured attached in system. Now, so working principle on optical pyrometer, an eyepiece at one end and object lens at other end. In figures, a power sources, battery, rheostat, and millivoltmeter to measure the current connected to a reference temperature bulb, and an absorption screen is placed in between the objective lens and reference temperature length. The absorption screen is used to increase the range of temperature which can be measured by the instrument. So, the red filament between the eyepiece and lamp allow only narrow band of wavelength of about this range, and operation of optical pyrometers is when a temperature source is to be measured, the radiation from sources are focused on to the filament of the reference temperature lamp using the objective lens. Now the eyepiece is adjusted so that the filament of reference temperature lamp is sharp focus and the filament is seen superimposed on the image of the temperature sources. Now the observer starts controlling the lamp current and filament will appear dark as in figure A. If the filament is cooler than the temperature sources, the filament will appear brightness as figure B. If the filament is hotter than the temperature sources, the filament will not be seen in figure C if the filament and temperature sources are the same temperature. So the third condition are generated. Now there are the three situations of filaments: filament A, filament B, and filament C. Filament A dark, filament B bright, and filament C disappear. So cooler than temperature sources at filament A conditions, and hotter than temperature sources that generate the filament B conditions, and filament C condition, equal brightness of filament and temperature sources. So now this condition is very important during the operation of optical pyrometers to measure the temperature. Now, hence the observer should control the lamp current until the filament and temperature sources have the same brightness, which will be noticed that when the filament disappear in figure C, in the superimposed image of the temperature sources, that is brightness of lamp and temperature sources are same at the instance the current flow through the lamp, which is indicated by the millivoltmeter connected to the lamp, because a measure of temperature of the temperature sources when calibrated. Now, advantage of optical pyrometers. So during the operation, some advantages are: physical contact to the instrument is not required to measure the temperature of the temperature sources. Accuracy is high provided proper size image of the temperature sources obtained in the instruments, and distance between the instrument and temperature sources doesn't matter. So now the instrument is easy to operate. So these are the very important advantage of optical pyrometers. Now, limitation of optical pyrometers. Temperature more than 700 centigrade can only be measured, since elimination of the temperature sources is must for measurements. Since it is manually operated, it cannot be used to continuous monitoring and controlling the purpose. So these are the limitation of optical pyrometers. Now, some major application of optical pyrometers are: optical pyrometers are used to measure the temperature of molten metals or heated materials in a metal casting system. So other application, optical pyrometers are also used to measure the temperature of furnace and hot body. So the big application of optical pyrometers are very important. Thank you.